Assalamu alaikum. Hi, everyone. Welcome to our webinar, Uncertainty and Risk Management in Oil and Gas Industry. I am Abdullah Abdurrahman, Business Developer in Reservoir Solution Company. I will do just a 5 minutes presentation, then Mr. Sardar will begin our webinar. Just our Reservoir Solutions is a company specialized in providing technical studies and courses for oil and gas companies and professionals. The company incorporates many professionals with diverse technical background related to oil and gas exploration and production. Our services include technical reservoir studies, field development planning, reservoir static and dynamic modeling, economic feasibility studies, technical support for academic researches like PhD and master degrees. Also, we are assisting in writing technical papers and publishment. Also, we are providing technical petroleum courses by industry expertise, and we provide mentorship programs. Just I wanted to inform you about our next course, which it will be static and dynamic reservoir modeling, and it will be 2 weeks hands-on workshop. For the course content, it will be 2 weeks hands-on experience, and it will be 100% practical course. By attending this course, you will enjoy lifetime access to recorded sessions, application datasets, application-based workshop. Course material also will be provided. We will have 2 days project at the end of the course to confirm full understanding for the course. Also, you will have open discussion with the instructor during and also after the course. At the end of the course, you will have certificate with online identification ID on our website. By the end of this course, you will be able to do well correlation, upscale with logs, visualize seismic outputs, do structural modeling, faults and surfaces, do facies modeling and distribute petrophysical properties into the 3D model, calculate the volumetric oil in place, static geological modeling QC, upscale the fine grids to simulation coarse grid, incorporate BVT and scale data into simulation model, learn well placement and design techniques, learn history matching principles, do production optimization and field development planning, do uncertainty and sensitivity studies for volumetric and simulation results. For the detailed daily content, I will send a link to view the course content. For our today webinar, the instructor for our today webinar is Mr. Sardar Kaya. Mr. Sardar Kaya is the managing director for Genergy LLC company. Also, he was senior geomodeler into Halliburton for 1 year. Also, he was a geomodeler into Abu Dhabi company for 1 year and 2 months. Then he was also a reservoir engineer into Calicar and Associates LLC for 2 years. Then he was also research associate about 2 years into University of Tulsa. About total of more than 23 years of experience into oil and gas experience. So for our webinar rules, please, if you have any questions, you can ask it into the Zoom chat, mute your microphone and camera. If you wanted to have a certificate for attendance of that webinar, please fill into the forms that will be sent into the Zoom chat. For upcoming courses and webinars, please join our Telegram channel and follow us on LinkedIn and other social media platforms. Contact us via mail and via our WhatsApp. Thank you all, and Mr. Sardar, you can start your presentation.
Hello all. I'm sure you are all you are from different parts of the world.
Yes.
Okay, so I want to make it a little bit interactive, this session. So can you write, okay, I can see your names. Can you write where do you live, okay, and your title and your experience in the area of oil and gas. How many years you have the experience into the chat room so I can see how much time you have spent and whom I'm talking to. So I will adjust my talk accordingly. Yeah. So let me share my screen.
Yeah.
Okay. So you can see my screen.
Yes.
Is there a problem?
I think that just we are seeing now a white board, a white screen.
How is it right now?
So I think it's uploading.
Is it now okay?
I think now, not yet.
It shows on my screen, it says live right now.
Okay, so you can stop sharing, then reshare.
Can you see it?
Yes, now we are seeing all the slides.
Okay, okay. I'm gonna put it in the presentation form right now.
Yeah. Yes, yes, it's a good
Okay.
now.
Okay, so very good. So I put this title, Uncertainty and Risk Management in Oil and Gas Industry. It's a big spectrum, okay? So my aim is to give you a flavor about the uncertainty, okay, and the risk management. Because oil and gas is a big spectrum. Let's go and see. There's upstream, downstream, midstream, and the issues are different, okay? It goes all the way from very technical subjects to very economical, very financial issues, okay? So when we say uncertainty, you know that the uncertainty is an issue that covers entire life. It's not only for any technical issue, or it's not only for one specific data. It's a life issue. For instance, okay, you want to marry, and then you are talking to the ladies, girls, okay, you want to marry, you are thinking that this girl is going to do this, do that at home. But you marry, and then everything will be different at home. So there's an uncertainty, you see. So you have to think about this uncertainty, people behavior, the financial issues, and so forth. So it's a life matter. So what you have to do, understand, okay, we have to live with it, and you have to understand how you can live with it, how you can handle, how you can manage the uncertainty. And as well as the oil industry is a giant industry, okay? It covers big spectrum of the activities fields, okay? All the way from exploration green fields, okay, with the geology starts, and then it goes on and on and on with the exploration, seismic, petrophysics, then the drilling, okay, and then it goes to the development. After development, you continue to recover oil or gas from your reservoir by EOR, and then you have to also transport your hydrocarbon that you are producing after a little bit of processing in the surface to the refining, okay, which is the midstream, okay, then you send it to the network, okay, in the world, okay, to your products. So it is pretty much covering a big chunk of activities and operations. So all over the activities has to be feasible, economical, technically sound, okay? And then it involves also a lot of governmental issues, legislations. So whatever you are doing, whatever you are gonna do has to be compliant with the requirements, okay, technical requirements. And then you observe, you make a lot of measurements, experiments, tests, observations from the field. All these observations, all these measurements involve lots of uncertainties because you have an issue with your equipment, with your yourself, your eyes, your brain, your thinking, your mood, okay? So it imposes lots of uncertainties on your data that you are making decision based on. And then this imposes also afterward risks, okay? Because you decide on one parameter and then you act on it, but that parameter, that value is uncertain. And because of this uncertainty, it imposes risks on your operations. So you have to know how you are gonna tackle with these risks. So let's see, okay, an example of the oil production. In year 2017, okay, it is around 100 million barrel, including consumptions, 100 million barrel produced and 100 million barrel consumed. 2017, 18, 19, then it suddenly dropped, 2020. And why this drop happened and who could estimate? You see, we have a forecast here. Let's put it down. We have a forecast here for the 2022 and 2023. It shows that more than 100 million barrel of production, but no one is estimating the uncertainty in this, okay? Because of the political issues, because of the health issues, like something like COVID, okay? Who could guess that the oil price was gonna go minus 35, okay? Negative price. Nobody could estimate, right? So our uncertainty range for the oil price is not from $60 to $110 per barrel. It's much wider, okay, much larger. So, and it's getting larger and larger because of the many issues, okay, technically with the global political issues, the wars. So it's a challenge for the oil and gas industry to understand all of this and then involve it in our operations, in our studies, okay? So a flavor today, how we are gonna do this, okay? Let's define the uncertainty. What is uncertainty? Uncertainty is the degree of inaccuracy in a measurement or predictions at a level of reasonable precision, okay? So I'm using two terms, accuracy and precision. Accuracy is the degree of right answer, how much you are close to the right answer, okay, with your observations or test measurements. Precision is the degree of detailness, okay? So with a reasonable precision, how much your observation is accurate, how much inaccurate is the uncertainty, how much accurate it is the certainty, okay? So all our data is little bit diverted from the actual data, from the right data, because of the tools, calibrations, observations, our interpretation or processing, okay? All this causes different types of uncertainties on your final results. What is sensitivity? Okay, there is a little bit of confusion on definition of uncertainty and sensitivity, okay? So let's clarify. Uncertainty is the degree of accuracy, and sensitivity is each parameter's impact on the final result, okay? Some data, some parameters have more impact with the change, the variation of the data is causing a higher impact on your results. Then it is highly sensitive to that parameter, we can call. So the degree of impact on the final results, okay? So uncertainty, and let me hide this. Okay, so the uncertainty and risk management and then the reporting of uncertainty, we have to talk the same language while we are observing, defining the uncertainty and reporting the uncertainty, and then how we are going to manage, mitigate our uncertainties and risk. We have to talk the same language. So the space of uncertainty is huge, okay? And out of the space, we have the uncertainty which imposes the risk, okay? We have to assess our risks, control them, and communicate with the parameters throughout the organizations, and then manage them, then do the planning, future decisions, management decisions accordingly, all those, okay? So this is kind of a mind map about the uncertainty management. So the another way of looking at the uncertainty is the risk that surrounds the future events and outcomes. So we are expecting this much of oil production for this much of period, plateau rate and plateau durations, and then we are expecting certain impurities from our reservoirs, from the wells, but it doesn't happen. So it is the risk of the outcome, okay, that doesn't happen around our predictions and around our conclusion. So uncertainty is the expression of the likelihood and the impact of any event with the potential to the influence of the achievement of the project's objectives. So at the end, what we want to do is to get results aligned, not actually our plan, our results aligned with the actual results from the field. Whatever the operations, we plan. And we have the data, we have the expectation from those observations, from the operations. So we want that to be close to our plan. If it's not close, that's the uncertainty envelope, okay? Where the uncertainty envelope can be defined, the value that we are expecting from our calculations and the value we are getting from the field, the difference is the uncertainty envelope. So we say that overall uncertainty is unavoidable. We cannot reduce the uncertainty 100%, okay? There is some degree of uncertainty always in all our life, okay? So we have to learn how to live with the uncertainty. It's kind of an information, okay? And we have to know how we are gonna search, make a research on this uncertainty envelope, define our uncertainty. And then with this envelope, the low case, high case, how we are gonna deal with it, okay? What are we gonna do? Say that we have the data coming from the field, okay? How we can define the envelope, plus after definition of the envelope, what are we gonna do with this low case, high case, P90, P50, P60? So that's the way how you deal with. And then it says that you have to make a case scenarios, okay? That's what nowadays, okay, the experts are advising. Because it is impossible to predict, okay? Everything is fluctuating. The dollar value is fluctuating, economy is fluctuating, political, the scenes are fluctuating. Because of the global climate change, okay, the weather is fluctuating. We are living the extreme cases, the highest season, the hottest season, the floods, and so forth. So what they are suggesting, okay, make scenarios, okay, make scenarios for all of these cases, and then think about what you can do, how we can capture if this happens. That's what they are advising, okay? It's a chronic issue, okay? It is persistent, you cannot remove. And then, of course, there are a lot of articles, a lot of studies about the uncertainty. Okay, let's continue. So the quantification of the uncertainty, so we have two parameters. We have already explained what is the accuracy, what is the precision with the reasonable detail, like the decimal numbers after the comma, okay? Let's think about the porosity. So if you are using fraction, Okay, for expressing the porosity, it has to be 4 digits after the comma. So 0.1256, okay, which means that 12.56%. Okay, so this type of rule of thumbs is going to help us while we are dealing with the Excel sheets, okay, with the data. So at the end, because we are getting different type of data from the field like core porosity and the log porosity, so we are going to work with them in the same environment in the model. So how we are gonna match with each of this data coming from the field? We have many issues like scale issue, okay? The core plugs is 2 centimeters, while the log data is from the search of investigation of the log tool. So there is a difference between them. How we are going to include all of these different data into the same environment, which is the model that we are trying to generate, okay? That's the experience, that's the understanding, that's the methodology, how we are going to deal with those issues. So what are the typical uncertainties that we can see? If there is a random error, we see that all our data are going up and down. Let's say that, okay, this cross plot is showing that the true score and the observations, that this line is the 100% accurate line. So our data point going up and down with almost the same amount. So if we draw the envelope, okay, for high case, we have to draw a line like this to cover the high side and another line like that to cover the low side. So it's going to be our envelope. But if there is a systematic error, okay, from the accurate 100% accurate value, so all our data are shifted in the same direction and almost same amount. So we have to capture this errors and make reconciliation, correction, before we include them in our model. So how we define the variability? Okay, the variability is the change of the magnitude of the change of any parameter in the geological process, in the petrophysical or reservoir variability, okay, reservoir parameters. So the magnitude of the change is called the variability, okay? How much our, let's say, well test permeability is gonna be different from the mean value, okay? That's the variation of the permeability, and from one location to another one. That's the variation due to the speciality, okay? The condition, the location. And then it's called also dispersion. We have to have the right population, okay? The number of the samples has to be enough to identify this variation. Otherwise, it's going to be a misleading, okay? Because at the end, we want to include in our predictions, okay, in our models, the variation in the data has to be the same in the model. So that's why it's important, not only the magnitude, not only the absolute values to predict the right one, but also the variation, okay? So the model uncertainty, getting the right model, does the model explain the data very well? Not only the value, but also the distribution, okay? Is the model consistent with the theory? Yeah, for instance, there is the positional environment the geologists are giving you. So is your model giving the results exactly same like the conceptual understanding of the positional model, the positional concept? So that's the consistency, okay? I love this term, consistency. At the end, whatever we are doing, okay, whatever the calculation, whatever the results we are getting, even the measurements we are getting, we have to like it by ourselves first of all, okay, before we pass it to our colleague, before we record it into the database. So it has to be the consistent result. So that's why we have to check from different angles, different views, okay? Otherwise, we increase the uncertainty. So getting the model right is different than getting the right model, okay? The difference here, getting the model right, is the model properly stated, worked? Are you using the right algorithm? okay? For permeability model, what you are generating, okay? The algorithm that you are using, are you using exactly the same for saturation model? Which doesn't work, okay? So getting the model right and getting the right model has to be there for certain results, for consistent results. So let's go, okay, few of the data that we are using. Seismic data. You know that the seismic data is in time domain, so we have to convert it into depth domain. And there are a lot of issues with the scale, vertical scale and the horizontal resolution, let's say resolution, okay? Vertical resolution is different than the horizontal resolution. So that is the issues with the seismic, okay? At the end, we have to use the seismic data together with log data, together with the core data, and there's a scale issue between them. How we are gonna manage this? So we have to decide what kind of algorithm we are gonna use it to incorporate all this data. And what do we get from the seismic data? We get the depth, we get the fault locations, we get the fault displacement, if possible. Most of the time, I don't think so we can get from the seismic displacement fault, the fault throw. And then we have to make some estimations. We have to make some assumptions, okay? And then we use the well markers. The most important issue in the well markers is the depth, okay? Has to be either wireline or the log data from the drilling, LWD, okay? These depths, and then from difference between the vertical hole and the horizontal hole. So there is issue in the depth for the well markers. We have to be careful. Okay, reservoir thickness, probably from seismic, or the thickness from the well data again, the reservoir top and the reservoir bottom. The difference is the thickness, and there's variation in that. There's a problem in that while you are defining, okay, difference from the seismic, difference from the markers. And of course, the markers is hard data, more reliable than the seismic. But at the end, we have the well data very limited, only at well locations. What do we do at the interval locations, okay? And the data, the depth data we are getting from the seismic has more uncertainty. So we have to see how we are gonna handle that. So the compartments, fluid contacts, fluid characteristics, facies model, water saturation, fractures, okay, fracture distribution, permeability, porosity, NTGs, all these parameters, okay? There are measurement side, there is the data availability side, and there is the processing interpretation results. All has to go together with each other. And more imposed, okay? During the measurement observations, we get uncertainty because of the tools. And then we impose more uncertainty while we are doing processing. The log data are processed, the seismic data is processed, and the well tests are processed and interpreted. So you see, every steps, we are putting more and more and more uncertainty. So we have to capture all of these. And then this is the breakdown of the uncertainty, okay? A different stage, different type of uncertainties we are getting. I don't want to spend so much time on this. And then that I already mentioned, the scale issue is not one of the most important issue from seismic, okay? We are getting one single signal, one signal every 30 meters, every 10 meters from seismic, while it is 1 to 2 centimeters from the log, okay? And then it is like 2 centimeters, 1 centimeter from the plug data. So you see from gigascopic to the megascopic, okay, it changed from 300 meters from the well test data that the permeability we are getting, okay, it goes to the microscopic scale, and the permeability we are getting also from the plug data. So well test is giving us the permeability. It's almost like 3-4 grids, while we are getting plug data, even not a grid, just 2 centimeters. So how we are going to manage this difference of the scale? It is an issue, and it creates uncertainty. We have to be careful while we are incorporating. So we have to develop an approach, okay? That's the important part of the job. So while we are dealing uncertainty from A to Z, we have to develop an approach and use this approach even from the planning stage, even from the A, we have to include uncertainty analysis and uncertainty management all the way from A to Z, okay? So it's not, the uncertainty management doesn't start at level of 2, 3, or 4, okay? You do your modeling, you do your processing, and you come at a stage to say that, okay, let me start the uncertainty analysis. No, it doesn't work, okay? If you do that, first of all, you miss the capturing the real uncertainty, okay? Because at this point, it's going to be difficult for you to go back and understand what are the causes, what are the scales, what are the issues, the magnitude, okay? All these are issues. But if you start from the beginning, you understand what are the possible causes of your uncertainty, and you generate your planning, generate your operations accordingly, it works fine. It works much better than starting from at certain stages, okay? So I said approach. It can be a stochastic approach or deterministic approach. Both are possible, or hybrid system. You include both of them. So we are going to see some of the workflow for this purpose. And then we make the analysis, okay? Statistical and quantitative analysis. So at the end, we have to address this issue to our management and to our board with the quantitative numbers. You cannot say, oh, our uncertainty is huge, okay? But what does it mean, huge? Oh, we don't have any uncertainty. What does it mean, okay? At the end, quantitative measures has to go there. Okay, for data processing, we have 2-3 issues, okay? After the data is transferred from the field to the geologist or geophysicist, there are uncertainties in processing, there are uncertainties in interpretation, there are uncertainties in also modeling, okay? So this is the list that possible uncertainties happens. After we conclude our uncertainty for each parameters, okay? So we have to think about what are the risks associated with each of these parameters. And after we define, okay, possible risks, we have to categorize them. We cannot go each of this type of risk caused by the permeability, caused by the porosity, by GRV, gross rock volume, or everything at the same line, same level. Because some of them impacts your project success much greater than the other. So you have to differentiate which one is more critical, which one is serious, which one is moderate, okay? So that's the risk assessment. After you define, then you have to attack all those risks based on their level. If it is critical, you have to work with it immediately, and you have to solve it. It's very important for the success of your project, so on and so forth. So after you define your categories, then you can put some coloring, and then you can use this coloring for a table like this. So you can say that, okay, geological number one, it's a structural mapping, the uncertain, inaccuracy in the gross rock volume, and what will be the impact, and then impact level, probability, risk, okay, manageability, and the timing issue. You can put all this coloring, and at the end, you end up with such a graph, which shows you what is the most important issues coming into this quadrant, okay? So, or this quadrant. So you can manage those issues, Geo01, Geo06, Geo04, based on this mapping, graphical illustrations. Our objective is to quantify, okay? And overall, we want to identify what are the parameters more uncertain than the rest, and which one of them are impacting our project success more than the others, and we want to reduce them, okay? Reduce to a certain level, we don't risk our projects, our operations. Okay, so there is a cultural, okay, corporate culture to tackle with these uncertainties, okay? So the transparency between the team members is extremely important. Unfortunately, people tend to hide the issues between them, okay? They want to hide it, they want to work on it separately, and then make it reasonable, then show it, then defend it. So we have to solve this issue. Everything has to be transparent on the table, and everything has to try to solve it together with different opinions, different views, because our brain only thinks in 3 dimensions. If we add the 4th dimension, 5th dimension, we cannot resolve. We cannot understand the issues. So it needs to be from different views, different angles, different disciplines. So we have been talking about in oil industry multidisciplinary environment. Actually, now it has to go to multi-industrial environment. So we have to bring biotechnologies. We have to bring space scientists into the table so we can improve our EOR. So instead of going steam or gas injections, we can go bacteria injections, right? So instead of producing hydrocarbon from reservoir, we can produce heat, geothermal, okay? So at this time of the human race, okay, we have to go out of box solutions. That's how we can achieve, okay, transparency between the team members and the well documentation, consistent results, okay, and the completeness. All the steps has to be completed properly, and we have to compare, okay, compare and understand better. We have to assess, okay, our uncertainties and go for the capturing them. So tornado chart is basically a tool that we use it to understand the difference of the sensitivity between the parameters, which parameter is affecting more than the others, okay? You see here, porosity is not really very effective. The change is happening only 10%, while the oil saturation is affecting 70%, okay, on the negative side, 60% on the positive side. So some of the people are discussing this tornado charts. They are saying that tornado chart is good, but it's showing only one parameter's effect, while the parameters, okay, all these porosity, saturation, gross rock volume are interconnected. Okay, yes, if you are changing in your model one parameter and getting the result to show here in the tornado chart, they are correct. But if you are doing all the steps while you change your porosity with the envelope you generated and then affect the saturations, affect the permeability, whatever, okay, the workflow that you're using, okay, from A to Z, a small change is all the way inherited, all the steps and the result, and showing in this tornado chart is different, okay? So that's the way how we have to do it. Even some of the companies are now doing the simulation also for alternative of these the multiple results, okay? We are generating with the stochastic data, they are applying the simulations also, okay? History matching, some of them, not all of them, because we don't have time to do that. And as you can, I'm sure, okay, all of you know Petrel. So Petrel is now including the uncertainty analysis within, okay, there is a workflow that you can run it. It says uncertainty and optimization. You can run and generate many results, as you can see here, and then check the stored as a result parameter, okay, check a hydrocarbon pore volume, whatever the parameters that you want, you can put it in a tornado chart like this. Okay, in the tabulation, in the tabular format, it shows the cases, what are the parameters you have used, and then the results. The oil industry, as I said, from the day one, while the field is green, okay, we start collecting a lot of data, okay, and then we do a lot of surveys. And that's why we have big data, okay? Day one, we have big data. Some of the industries, they collect the data and then they say that, okay, they have the big data. But in our industry, from the day one, we have the big data. So we have to, the data management issue nowadays with the artificial intelligence, machine learning, and then collection of the data with IoT, Internet of Things, okay, with the new developed sensors, it's getting bigger and bigger and bigger. So we have to, okay, our uncertainty, our modeling, our interpretation has to be aligned with this development. Otherwise, they develop, but we are at the back, okay? And the gap is increasing more and more. So we have to update ourselves, our team, our company, by using these new technologies. So this is kind of a map, okay, data flow map in oil industry from greenfield to exploration, appraisal, development, enhanced recovery, and until the abandonment, we keep collecting data. And I like to get time to talk about all these, okay, steps, all these disciplines, what data they are collecting, how we have to, okay, incorporate them, what are the typical issues, how we can troubleshoot. I like to take this time, but unfortunately we have limited time. Maybe we can arrange another meeting. So as I said, for the top structure, for the volume, we have the well data at certain locations, right? So we have limited wells. So we have to keep the markers from the logs, okay, as the certain data, but at interval locations, we can generate kind of uncertainty map, okay, and calculate based on this. It can be stochastic, okay, if we generate randomly, okay, this change between the high case and low case, so it's going to be a stochastic. If we want to fix, okay, away from the well location, it's going to be deterministic uncertainty. So we have uncertainty at the top structure, but also at the flow contact values, contact data, okay? Because fluid contacts are also uncertain, and the transition zone uncertain, okay? Because we have different techniques to measure the contact, okay? So each technique is giving us different data. So our uncertainty envelope is defined the difference between these techniques. So when we look at, for instance, core porosity and the log porosity, their histogram, their mean values, their standard deviations, okay, it tells us the difference with respect to this scale with these techniques, and then we can use this difference as the definition of range, okay, uncertainty range. So what we can do also to generate multiple realizations of one parameter, and then see, we go with the descriptive statistics of each realizations, okay, generate the parameters like mean value in each realizations here, okay, you see the difference just by running the whole stochastic SGS, for instance, with different seed number, and then our mean value change. So this difference, okay, the highest, the lowest, it gives us the uncertainty because of the seed number, okay? And then we can use different techniques like SGS, kriging, and so forth. I'll show you a flow diagram right now, and then see what's changing, okay? Just because of our modeling techniques. Okay, this is the workflow, okay? You see, I used in one branch porosity model by SGS, okay, with collocatic covariating, and SGS with the data range variogram. I played with the variogram, I played with the seed number, correlation coefficient, trends, okay, using different trends, using different algorithms, kriging and SGS, and I generated all these multiple realizations. Where I have used both deterministic and I use stochastic together, and then hybrid system generated multiple realizations, then I made the ranking to define what's changing. So we have the variation both in vertical and the horizontal axis, okay? So each axis defines the histogram where is the data is accumulated and where it has the range, okay? So this makes the difference, okay? Let's see this histogram, okay? You see, this is the squares where you see is the data. And as you can see, there's high perm points here, which defines the high case. And if you put it down to the lower limit of the data, okay, then you can generate the uncertainty. Because most of the time people ask, okay, how we can define the uncertainty map. Generally, they go with the deterministic technique. They generate like 10% more, 10% less, but it's better to go with the statistical techniques and the algorithms that we are using, okay? So the sample, okay, the number of the samples we are collecting, I showed you with the number of realizations, okay? If we do one case, it looks like this, 10 cases are like this, 50 cases, and then if we increase to 10,000 cases, it looks like a normal distribution, right? So the number of the samples we are collecting or we are practicing, okay, it makes the difference. So at the end, what we have to think about, any data samples, any results, or any realizations numbers, we look at the histogram, okay, the difference, but we have to think, if we collect 10,000 cases, how does it look? Okay, and then we can put the mean value and the variation according to this one by considering this type of incidents, right? Okay, and as I said, that it's an experience and knowledge how to tackle with this uncertainty, okay? If you have, for instance, problem with your PVD data, what kind of data you have to collect? If you have problem with the productivity, okay, what kind of data you have to collect? And you can generate a map for your uncertainty of each parameter and then overimpose each of them to find the most uncertain area and then make decisions for your field operations accordingly. Okay, so there are lists, of course, okay, like geological data and the uncertainties generated from this, seismic data, okay, the velocity model, petrophysical data, and dynamic data. And data gathering program has to be according to your definition, your interpretations, okay? You generate a map for the uncertainty, and then you check your sensitivity parameters also, which of your uncertainty is more sensitive, because we have limited time, limited budget, limited resources. We cannot do the analysis and we cannot reduce all the uncertainties at once. So we have to go with the highest sensitivity, higher sensitivity parameters and the most uncertain area, okay, to make our interpretation modeling and simulations much accurate. So as I said, generate the map for each parameter, superimpose on top of each other on the map, and then look at the regions which is more uncertain and make your decisions accordingly. So as a conclusion, what I can say, uncertainty analysis starts from the early stage, okay? And then it goes with every step. You collect the data, you look at your uncertainty. You make a statistical analysis of your initial data, raw data, let's say, you look at it. You make the processing, you look at your uncertainty and how much you have made the change between raw data and processed data, and then interpreted data. What are the differences? Descriptive, statistical parameters difference between each step, okay? Along the modeling work, analysis can be incorporated into the workflow. So that's, okay, as you have already seen, I have incorporated the uncertainty analysis into the workflow that I am using, yeah? So it's not at the end, but while you are working, while you are generating workflow, think about this and incorporate it. Uncertainty parameters can be evaluated by stochastic or deterministic way or hybrid. And conscious data planning can reduce the uncertainty significantly. So we have to consciously do our operations, okay? Make decisions, make a data gathering program to tackle with our uncertainty issues. So that's all from me. If you like to, if you have questions, I would be happy to address actually.
Thank you, Mr. Sardar, for this interesting and informative session. So for the attendance, please, if you have any question, drop it into the Zoom chat.
Apparently, we don't have any questions. So everything understood very well.
I think that we have a question here. Can we assign uncertainty and risk management together?
There are two different things, okay? We shouldn't mix both of them. And then the uncertainty analysis is completely different than the sensitivity. And both of them has to be performed properly, okay? Some of the risk management, okay, has to evolve from operation side, from other departments. That's why they are different.
Yeah. We have another question. How can we reduce the uncertainty related to scale problems?
Actually, the scale problem is more not the uncertainty reduction, but it's more related to your way how you are handling. Like I said, for instance, you know, you are getting the reservoir top from seismic, and you are getting also the markers how you are going to handle. You are getting permeability from well test, okay, and you are getting permeability from core data, how you are going to handle both of them. And actually, what we have experienced, if you can generate a workflow to incorporate both of them in a right way, it helps a lot. Okay, for instance, I will give you an example. We know that seismic resolution in horizontal way in spatially, it's very good, okay? And then the vertical resolution of the seismic is not good. That's why if you have a seismic inversion or attribute analysis, you have to use the aerial distribution of those results from the seismic to use this distribution in your modeling, but not right directly, okay? Indirectly, you have to get the aerial distribution understanding from the seismic and incorporate in your property model. And the same thing with that well test. If you have the well test permeability, you can use it to generate a permeability property by using the core permeability in the vicinity of that well test while you are doing modeling, okay? If you incorporate at the modeling stage of the permeability, when it goes to the simulation, okay, it will be history matched immediately. So there you see, you know, if you use the right technique, right step, right time, then you get a lot of benefits from the scale issue, not the problem, okay? But you have to be very experienced to see at what level you are going to incorporate different scale data.
Yeah. Okay, thank you. So I have another question. Which is more useful, CCS, EUR, or biological EUR?
I don't think so. This is a question for our scope. It's more than me.
Okay.
Let's go to the next question.
Yeah. So the next question, how may I weight the uncertainty between permeability calculated from well testing and from core?
As I said, the scale issue is not telling that this data is more accurate than the other, okay? So it's a way how you are going to incorporate. So the permeability, well test permeability is giving you much larger scale sense, okay? Rather than the core permeability. So let's say that you have the core data, okay? You put in the cross plot and then check where does your well test permeability locates, okay? If there's any missing section from the perforated interval, let's say that, okay, you have perforated interval from A to A depth to the B depth, but there is a missing of the core from that section. So use the well test results, okay, to assign permeability values in that missing section. And then at the end, you generate multiple realizations of the permeability and see which one is giving you average permeability aligned with the well test results. So use that one for your end product going to the simulation engineers. Okay, so you see, it's not a direct, okay, waiting or saying that this is more correct or something. It is the workflow that you are using. Okay.
Okay.
So I guess that's all. No more questions.
We have another question. What if the vertical resolution of seismic is 8 to 9 meter and reservoir thickness is under 25 meter? Can this give uncertainty with marker and horizon interpretation?
It is okay. You see, the reservoir top is not related to the vertical resolution. It's related to the seismic peak. The geophysicist is picking, yeah? And they are looking at the seismic profile. So they assign at one point, okay, between the signals, and then they say that this is the point at this location the reservoir top is, okay? So if you are saying that the resolution is 8 to 9 meters, it means that the geophysicist can put the peg 8 meter up and 8 meter down, right? So it is going to generate an uncertainty envelope or 20 meters. So that's what you have to consider.
Yeah. I think that we have another question. According to your experience, which one is the most effective argument to make production managers to join an uncertainty approach to oil production?
Production engineers, okay, how we can bring their experience and knowledge into the table. It is production data is a dynamic data, so it has to come together with the reservoir guys, okay? And of course, you know, if we sit down, think about how we are going to incorporate, there is a value in it. Definitely, there's a value in it, okay, to generate the model early stage.
Yeah. So we have the last question. I have one question. Which one of them to calculate volumetric STOIP? Near approach, realistic with stochastic, probability, and deterministic, based on your experience?
Yes, okay, good question. So we are gonna get stochastic results, we are gonna get probabilistic results, and we are gonna get deterministic results. My suggestion is to use all of them, okay? So because each of them is going to give you a chance to analyze and to report in different way, okay? So if you use, for instance, stochastic way, and it's going to give you multiple realizations. And then out of these multiple realizations, you can analyze the outcomes, how it is impacting your project results. For probabilistic, it will give you the chance to run the case again and again and again within a short period of time, and then generate the distribution curve out of this to use the curve, okay, normal distribution for your deterministic case where it locates. So each of this technique is providing a different type of results, okay? And each of this result is helping you from the different views, okay? Different statistical, let's say, descriptions, okay?
Okay. So in the end, I thank you, Mr. Sadar, for that interesting and informative session. I think
it was my pleasure.
I think that all the attendees have some new information to add to them to their experience. So thank you again, and hope to see you later into again and again more and more sessions, inshallah. Also, thank you for the attendance, for your attention and for your questions. Again, in the end, just to remember that if you wanted to give or to have an attendance certificate for this webinar, please fill into the form that will be sent into the Zoom chat. Also, again, we have into this month, we have a course for static and dynamic reservoir modeling. So if you wanted to enroll into that course, you can also register by the link that will be sent into the Zoom chat. Thank you again, and hope to see you later into other sessions, inshallah. Thank you. Assalamu alaikum.